So now we're going to simplify a couple of expressions using some familiar angles. Now that we've introduced the 30, 60, 90 right triangle as well as the 45, 45, 90 right triangle, we're going to use these to simplify some trigonometric ratios. So first one, pretty straightforward. 2 times the sine of 45 degrees plus 4 times the cosine of 30 degrees. Taking a look at our 45, 45, 90 right triangle, the sine of 45 degrees is expressible in one of two different ways. We could either call it 1 over the square root of 2, or the other thing that we had for this is if we rationalize the denominator, we can call it root 2 over 2. I'll explain why we want to do that in just a moment. For the cosine of 30 degrees, from the perspective of the 30-degree angle, the adjacent side is root 3, the hypotenuse is 2. That lets me know that the cosine of that angle is going to be root 3 over 2. Now the reason that I express the sine of 45 degrees in this form rather than 1 over the square root of 2 is because we're about to multiply by 2, and that'll cancel out the 2 really nicely. This will be the square root of 2 plus. For the second fraction, we can consider this 4 to be 4 over 1, and say that the 4 and 2 can reduce down to a 2 over 1, leaving me with 2 square roots of 3. I have no intention of doing anything else with it, so we will leave it in this form. Square root of 2 plus 2 square roots of 3. For our second example, we see that this time we've been given an angle measured in radians. So, as a quick reminder to ourselves, though we should start familiarizing ourselves with radians as much as possible, it's okay to reference back to degrees should you need to do so. So pi over 3 is the same as saying a 60-degree angle. So going up to our 60-degree angle, the tangent of this would be the opposite side over the adjacent side. So the opposite side over the adjacent side would be root 3 over 1. Then we've been asked to square this. Now dividing by 1 doesn't really do anything, so we're left with 4 plus root 3 squared. When we square the square root of 3, we'll wind up with 3. 4 plus 3 winds up giving us 7 for a final answer. Now for the next example, there is a bit of a pitfall on this one. We're told the secant squared of 60 degrees minus the tangent squared of 45 degrees. This looks very, very similar to a Pythagorean identity. Pythagorean identity states that if you have the secant squared of theta minus the tangent squared of theta, that's going to be equal to 1. This is not the case in this problem. Why is that? Because this one requires that these two angles be equal to each other, and these two angles are not equal to each other. As a result, what we're going to do instead is go back to our two familiar triangles from up the top of the page. Now the first one is supposed to be the secant squared of 60 degrees. So secant is supposed to be the reciprocal of cosine. So let's make a little note here that says that the cosine of 60 degrees would be the adjacent over the hypotenuse. That would be 1 over 2. Therefore, the secant of 60 degrees is going to be the reciprocal of that. So down here, this means that the secant of 60 degrees, that'll be equal to 2. Now as far as the tangent of 45 degrees is concerned, tangent is going to be the opposite over the adjacent for the 45-degree angle. That will be equal to 1. Or 1 over 1 if you prefer. So now we're looking at 2 squared minus 1 squared. We can simplify that to 4 minus 1 for a final answer of 3. If you can combine the like terms, please do so.